1938. Berlin, the Reich Air Ministry. In a grand hall, blueprints are spread across a massive wooden table. For a moment, there is a deathly silence. Then, one of the officers recoils, shoving the papers away as if they were white-hot coal. "Is this a joke?" he barks. "An aircraft like this cannot exist. It'll flip on takeoff and kill the pilot." The room erupts into chaos. Men leap from their chairs. Others clutch their heads in pure disbelief. On those blueprints is a machine that defies everything German aeronautical engineers have ever been taught. The cockpit is offset to one side. The engine is housed in a separate fuselage. The central axis is gone. Symmetry has been broken on purpose. According to every established law of aviation, such a machine should spin out of control before its wheels even leave the tarmac. "This isn't an airplane, it's a circus act," one official sneers. "The Luftwaffe will not fly this monstrosity." In the world of aviation, there was one rule that was never up for debate. An aircraft must be symmetrical. To break this rule was to invite death. And yet, there it was, lying on the table, shattered. Standing by the wall was the man who had brought these drawings. His name was Richard Vogt, and he was the only one in the room who wasn't shouting. Richard Vogt was neither a dreamer nor a mere desk-bound theorist. By this point, he was 40 years old and already had one war behind him. During the First World War, he served as a reconnaissance pilot, flying fragile aircraft over the front lines. He knew all too well how design flaws ended. He had seen planes disintegrate in mid-air and watched pilots perish not from enemy fire, but from engineering failures. After the war, Vogt remained in aviation, quickly earning a reputation as a difficult man. He had no love for following established rules. He didn't believe in doing things the way they've always been done. He always questioned what others preferred to leave unchallenged. In aviation circles, the consensus on him was always the same: talented, stubborn, and dangerous. Vogt didn't seek to improve existing designs. He wanted to tear them down completely and rebuild them according to his own logic. It was exactly this mindset that brought him to that office in Berlin, where minutes ago, officials stared at his blueprints in horror. The story of this project began several months earlier. The Reich Air Ministry, RLM, announced a competition for a new tactical reconnaissance aircraft for the Luftwaffe. The requirements were crystal clear. The machine had to carry a crew of 3 and provide a maximum field of view for observing enemy territory. It needed to be fast enough to outpace interceptors and stable enough for long-range reconnaissance sorties. But among all the technical requirements, there was one non-negotiable point. The aircraft had to be single-engined. The ministry was adamant about this principle. One engine meant a simpler design, easier maintenance, lower fuel consumption, and faster production. Germany's leading aviation firms were invited to compete: Arado, Focke-Wulf, and several other renowned design bureaus. Blohm and Voss wasn't even on the list. They specialized in seaplanes and flying boats, not land-based scouts. Technically, Richard Vogt wasn't even supposed to be part of this competition. Yet it was the very rigidity of these requirements that became his starting point. In those years, almost all aircraft were built according to the same blueprint. Engine in the center, cockpit right behind it, wings symmetrical on the sides, tail strictly along the axis. This configuration was considered the only correct way. It looked logical, familiar, and had been proven for decades. But Vogt saw problems where others saw virtues. First, the engine blocked the view. The pilot and observer had to look forward through the spinning propeller and a massive cowling. The most critical direction for reconnaissance was partially blind. Second, the slipstream from the propeller battered the control surfaces. The plane constantly struggled to veer off course. The pilot had to continuously correct the flight path. And finally, the most important factor: the engine's torque created an asymmetry that every pilot had to fight. It was a strange contradiction. Planes built to be symmetrical actually flew asymmetrically in reality. Vogt asked the question no one else dared to say out loud. What if the problem isn't the pilots? What if the problem is the layout itself? Vogt looked at the problem differently than his colleagues. He wasn't trying to fix the symptoms. He decided to eliminate the cause. If a symmetrical plane flies asymmetrically anyway, then perhaps the opposite approach is needed. Create an aircraft that is asymmetrical in design but symmetrical in flight. Place the engine not in the center but to the side. Remove it from the crew's line of sight. Shift the cockpit to maximize the field of view, and calculate the wing's lift to compensate for the weight imbalance. It sounded like madness, but in Vogt's calculations, everything added up. He wasn't breaking the laws of aerodynamics, he was using them against conventional patterns. The question was no longer technical, It was philosophical. Was aviation ready to abandon a symmetry that only existed on blueprints? Vogt had no support from the ministry, no contract, no official entry into the competition. But there was one man on whom far more depended than any bureaucrat: Walter Blohm, the owner of Blohm and Voss. Unlike the military bureaucrats, Blohm had a broader vision for aviation. He understood that war isn't eternal, and that military contracts would eventually be followed by civil aviation. And he knew that the victors wouldn't be those who copied old designs, but those who dared to be first. When Vogt showed him the blueprints for the asymmetrical aircraft, Blohm didn't laugh. He didn't kick the designer out of his office or call it insanity. He saw an opportunity, a chance to stand out, a chance to create a machine that people would talk about, and perhaps a chance to change the very approach to aeronautical engineering. Blohm gave Vogt permission to begin development. This was despite the fact that the Air Ministry hadn't even invited them to the competition. From that moment on, the project ceased to be just an idea on paper. It became a real machine that had to be built. Vogt immediately refused any compromises. If the plane was to be asymmetrical, it would be asymmetrical in every aspect. The BMW engine was placed on the left, in a separate fuselage that extended to the tail unit. On the right sat a fully glazed crew nacelle made of plexiglass. 3 men, the pilot in front, the observer in the center, and the gunner in the rear, sat not in tandem, but in a space designed primarily for visibility. The wing connected both parts of the structure and served several purposes at once. It didn't just generate lift, it compensated for the weight offset. The load distribution was calculated so that the aircraft remained stable despite its outward asymmetry. The view from the cockpit was nearly fantastic. The crew could see the ground below them, the sky above, the space to the sides, and even to the rear, without an engine or fuselage blocking their sight. No other single-engine aircraft of the time could offer anything like it. On the blueprints, it looked bold. In the calculations, it looked logical. But in reality, the plane looked as if it had been assembled from 2 different machines and simply joined by a wing. When the prototype was rolled out onto the airfield, the chatter died down. The aircraft stood on the tarmac, no longer a drawing but a physical reality. And it looked wrong. It was too crooked, too unbalanced. Mechanics circled the machine, stopping, stepping back, and shaking their heads in disbelief. The test pilot tasked with taking it up remained silent for a long time, slowly walking around the plane and muttering under his breath as he examined the details. No one believed this design could fly normally. Some even placed bets that the plane would either fail to lift off or immediately roll onto its side and crash upon takeoff. Vogt stood to the side, fists clenched. He appeared calm, but he knew, if this first flight ended in disaster, his career would be over, and the idea of asymmetrical aircraft would be buried forever. The engine roared to life. The propeller gathered speed and the aircraft slowly began to taxi. As it gained velocity, the structure vibrated and rattled as if it were about to fall apart. No one looked away from the runway. Everyone expected the same thing, for the machine to suddenly veer off course or dip a wing, but it didn't happen. The plane continued to accelerate smoothly, without jerking or tilting. Then, the nose lifted, and the asymmetrical craft broke contact with the earth. For a few seconds, a deathly silence hung over the airfield as people held their breath, waiting for something to go wrong. But the plane climbed steadily. It completed 1 circuit over the airfield, then a second. The pilot performed several maneuvers, calmly, without any sudden movements. The machine handled as if the fears and calculations of the skeptics had never existed. When the plane finally landed and the pilot climbed out of the cockpit, he was pale and visibly shaken. But his first words sounded like a final verdict for the doubters. This machine flies better than many conventional aircraft. News of the successful test spread fast. By the next day, the entire aviation community was buzzing about the strange new plane. One of those who took an interest was Luftwaffe Colonel General Ernst Udet, a legendary ace of the First World War. Udet wasn't just a bureaucrat. He was a pilot who understood aviation through instinct, not just reports. When shown the flight logs, he demanded a personal demonstration, and Vogt agreed without hesitation. Udet arrived at the airfield, inspected the aircraft thoroughly, asked dozens of technical questions, and insisted on going up himself in the observer's seat. After the flight, his doubts vanished. He declared that the machine met nearly all the ministry's requirements and, in several areas, surpassed traditional reconnaissance planes: visibility, stability, maneuverability. Udet promised Vogt his support and began pushing the project through the highest echelons of power. At that moment, it seemed the hardest part was over. The system had finally listened to the engineer. But in Berlin, there was one man who saw this story very differently. Udet's support didn't guarantee an automatic victory. There was another center of power within the Luftwaffe. At the head of the Third Reich's Air Force stood Hermann Göring, commander-in-chief of the Luftwaffe and one of the most powerful men in Germany. Unlike Udet, Göring was a conservative. He disliked experiments and distrusted designs that looked too unorthodox. When he was briefed on Vogt's asymmetrical plane, his reaction was cold. He dismissed the project as a circus act. He doubted such a machine could ever be reliable in combat conditions, and made it clear he wouldn't risk the Luftwaffe's reputation on engineering experiments. Göring preferred proven solutions, aircraft that looked right, symmetrical, predictable, and he already had a favorite. The Focke-Wulf Company had submitted the FW-189 Uhu, the Eagle Owl, to the competition. It featured a classic twin-boom design with two engines and a central glass gondola. Technically, this plane violated the ministry's requirement for a single-engine design, but Göring was willing to turn a blind eye. Two engines seemed more reliable than one, and symmetry looked safer than any revolutionary idea. Now, the fate of Vogt's project depended not on calculations or tests, but on a clash of ideologies within the system itself. On paper, the ministry's favorite looked convincing. The FW-189 matched the leadership's vision of what a scout plane should be. Two engines meant reliability, a symmetrical layout meant predictability, and a familiar configuration meant fewer surprises for the pilots. This was why that plane was the first to be sent for extended trials. However, in the air, its advantages quickly turned into liabilities. Two engines meant more weight, higher fuel consumption, and shorter range. Most importantly, it meant maintenance was a nightmare in field conditions. The aircraft proved to be sluggish, struggling to climb when fully loaded. Maneuverability was lacking, and its speed barely allowed it to escape enemy interceptors. Pilots noted that while the machine was fine for patrolling the rear, it was ill-suited for reconnaissance over the front lines. Against this backdrop, Vogt's asymmetrical plane looked like an increasingly attractive alternative. It was lighter, faster, and more economical. While the ministry continued to argue over aesthetics, the facts and figures in the air began to speak for themselves, and they were not in favor of the system's darling. To end the disputes, the Ministry of Aviation ordered comparative trials. 2 planes, 2 approaches, 1 commission. The tests followed an identical program: takeoff with a full load, range flights, low-altitude maneuvers, and landings in difficult conditions. The FW-189 performed predictably. It completed its tasks accurately, but with no margin for error. Any overload immediately impacted its performance. Vogt's plane behaved differently. It climbed faster, held its course better, and remained controllable in situations where the twin-engine machine began to drift. But the main advantage revealed itself during reconnaissance. The view from the glazed nacelle allowed the crew to see things that pilots of other aircraft simply missed: targets directly under the wing, in front of them, and to the sides. The commission recorded the results in the protocols. The numbers were dry, but the conclusion was clear: the asymmetrical aircraft outperformed its competitor in key reconnaissance parameters. Formally, the system had to recognize the victory of the machine that looked the strangest of all. The trial results were impossible to ignore. Even the most skeptical officials were forced to admit Vogt's plane worked. Soon, the Air Ministry made its decision. The project received official status, and Blom and Voss were authorized to begin serial production. The contract was impressive, involving several hundred aircraft. For a company that, until recently, wasn't even allowed in the competition, this was nearly unbelievable. Euphoria reigned in the design bureau. Vogt, once dismissed as a madman, was suddenly hailed as an innovator who had proven his point. The project was designated the BV-141. Discussions began regarding future modifications, refinements, and expanding its roles, from reconnaissance to artillery spotting. It seemed the experiment had not just succeeded, it was a triumph. But it was at this very moment that the story of the asymmetrical plane took its first wrong turn. With the launch of the series, the project ceased to be an experiment. It became a part of the war machine. Blohm and Voss factories began preparing production lines, and designers refined the blueprints for mass manufacturing. Each plane now had to be more than a flying prototype. It had to be a mass-produced product of war. This is where the first complications emerged. The asymmetrical design required high precision in assembly, with minimal tolerances. Any error in balance immediately affected handling. Production moved slowly. Each aircraft required more time than standard machines, and some components had to be crafted by hand. Simultaneously, changes began to be introduced into the design. Armament was reinforced, equipment was added, and crew protection was improved. The plane grew heavier, and with every such improvement, it drifted further away from the light, elegant machine that had so impressed the Commission during trials. When the first production aircraft began reaching units, illusions quickly vanished. In combat conditions, the asymmetrical layout revealed its other side. What worked on a test range proved far more difficult on frontline airfields. Pilots complained about the engine, which overheated during long flights at low altitudes. Maintenance required more time and attention than standard scouts. But the main problem lay elsewhere. The aircraft proved vulnerable. Its unusual configuration made it a difficult target for its own mechanics, but a convenient one for enemy gunners. Limited armor and the lack of full engine protection began to take their toll in the very first combat sorties. Pilot reports grew increasingly cautious. They no longer contained excitement, only dry phrasing and a growing doubt that this experimental machine could survive for long in a real war. Every attempt to solve one problem gave birth to two new ones. To handle engine overheating, engineers reinforced the cooling system. This added weight, which shifted the center of gravity. To restore stability, they had to redistribute the load on the wing, change structural elements, and reinforce the airframe. The plane grew heavier again. The increased mass demanded a more powerful engine, but installing a different motor meant new calculations, new tests, and essentially, a new aircraft. The armament was also constantly revised. Additional machine guns appeared, and the ammunition load was increased. Crew protection was strengthened. Every improvement seemed logical and justified, but together they destroyed the original vision. The aircraft that had won due to its lightness was losing its speed, its range, and its maneuverability. Vogt realized the project was caught in a trap. To meet the demands of war, it had to be constantly complicated, but the more complex it became, the less remained of the idea that started it all. To save the project, designers began releasing updated versions. Each one was supposed to fix the errors of the last. Structural elements were changed, aerodynamics were revised, new instruments were added, and crew protection was increased. The aircraft became increasingly complex, less standardized, and more demanding to produce and maintain. What was once an advantage had turned into a burden. The asymmetrical design meant that almost every part was unique. You couldn't simply take a component from another aircraft or quickly replace a damaged element. In wartime, this was critical. While Blohm and Voss engineers tried to perfect the project, other planes were already flying, fighting, and being produced by the hundreds. Each new version of the BV-141 looked better on paper but fit worse into the reality of the front lines. The project wasn't a failure yet, but it had already ceased to be a priority. By 1941, it became clear that the original BMW engine lacked the power to handle the increased weight of the production models. A replacement was needed. Vogt decided to switch to the more powerful BMW 801, the same engine used in the legendary Focke-Wulf 190 fighter. On paper, it was the perfect solution, but in reality, it was a death sentence for the project. The BMW 801 was in extremely high demand. Every single engine was designated for frontline fighters that the Luftwaffe needed by the thousands. The Ministry of Aviation faced a choice: give engines to a mass-produced proven fighter or to an experimental asymmetrical reconnaissance plane. The choice was obvious. The BV-141 was moved to the bottom of the priority list. Production, which had already been slow, practically ground to a halt. The final blow came not from the drawing board, but from the logistics department. The ministry officially canceled the large-scale contract for the BV-141. Only a small batch of aircraft, around 20 to 30 units depending on different records, was ever completed. Most were sent to the Eastern Front, where they were used for secondary tasks. They flew, they performed reconnaissance, and sometimes they even returned with valuable intelligence, but they could no longer change the course of the war. Against the backdrop of thousands of symmetrical planes, these few asymmetrical machines looked like ghosts of a future that never arrived. By 1943, the project was effectively dead. The factories were repurposed for other needs, and the unique blueprints were archived. As the war neared its end, the fate of the remaining BV-141s became a mystery. Most of the aircraft were destroyed by the Germans themselves during their retreat to prevent the technology from falling into enemy hands. Others were lost in Allied bombing raids. By the time the war ended, not a single intact BV-141 remained on German airfields. They seemed to vanish, leaving behind only photographs and the testimonies of those who had built and flown them. When British and American troops entered German territory, they found many unusual designs, but the BV-141 caused a particular sensation. In the ruins of one of the factories, Allied engineers discovered the wreckage of several aircraft. They carefully studied the remains, trying to understand the logic behind the design. They photographed every detail and examined the wing structures and the offset cockpit, but their interest was purely academic. Neither the Americans nor the British had any intention of putting such a machine into production. To them, it was an engineering curiosity, a what-if from a defeated enemy. Today, you won't find a BV-141 in any museum in the world. Not a single complete airframe survived the war and the post-war scrap heaps. Several decades ago, rumors surfaced that parts of the tail or wing had been found in the forests of Eastern Europe, but these remained unconfirmed. All we have left of the most unusual aircraft of World War II are black and white photos, factory blueprints, and digital reconstructions. The machine that dared to be different vanished almost without a trace. The BV-141 did not become a trophy that other nations rushed to copy. Instead, it became an object of study, an example of what engineering can achieve when given absolute freedom. It proved that the rules of aviation are not as rigid as they seem. You can break symmetry and still fly. You can defy tradition and still succeed technically. But the BV-141 also served as a warning. In a total war, a brilliant idea isn't enough. You need simplicity, reliability, and the ability to produce thousands of identical machines, things that a revolutionary design, by definition, cannot provide. After the war, Richard Vogt found himself on the other side of history. Germany was defeated, the Luftwaffe ceased to exist, and the Third Reich's aviation projects became spoils of war. But Vogt himself did not disappear. Like many German engineers, he was brought to the United States. The Americans weren't interested in his past. They wanted his ideas and experience. Vogt worked in the American aerospace industry, contributing to new designs, aerodynamics, and aircraft layouts. However, he never built another asymmetrical plane. His knowledge was utilized and his expertise was valued, but his boldest idea remained in the past. The man who challenged the fundamental rules of aviation survived the war, changed countries, and continued his career as an engineer. His aircraft, however, did not. The story of the BV-141 is not a story of failure. It is a story of the limit, the point where engineering courage meets the brutal reality of mass production and war. Richard Vogt showed that a wrong plane could fly better than a right one. He proved that the greatest obstacle to progress is often not the laws of physics, but the habits of the mind. The BV-141 remains a monument to a time when people weren't afraid to ask, why not? Even if the answer cost them everything. It was a machine that was too unique for its time, and perhaps that is why it stayed there forever.